Alrighty, after a long grind of my scuffed math class, I have finally finished. So, if you haven't watched my previous two basically live stream videos of me coding the scuffed math class, essentially what I did is that I coded my own version of the math and strict math Java classes in the standard Java language library because I decided that it would be a great way to, easily work on a class where using the um the computer science knowledge that I've gained from my computer science courses, this is one that I could work on my own, unlike something more advanced like a graphics class. This is one 100% that I can create my own methods using conditional statements, looping structures, and my knowledge of, basic object oriented programming, with, methods and, static final keywords and that sort of reason, and I would be able to create my own version of the math class. Hence why I named it Scuffed Math, because obviously it won't be perfect, because I, as a mathematician, am not perfect, and as a computer scientist, I'm not perfect, so of course there are going to be mistakes here and some shortcuts. So the first thing that you see here is that I created two um, private static variables called pi and e. The first contains the first 5 digits of the number pi, and then of the mathematical e, I just copied and pasted, I think, the first, let's see here, 7 digits of it. So this is already the scuffed part. Obviously, the more digits I would add, the more accurate both of these variables could prove in some of the algorithms that I have. But because it's scuffed and I really didn't want to type out anything and I wanted to do it on my own as possible, I just stuck with these from what I could remember from pi and just copied and pasted the first 7 digits of mathematical e. Next, and I also created them private, even though I created them final, because I wanted to use accessor methods because I like implementing as much object-oriented programming to help my own understanding, to reinforce ideas and concepts that I learn in class, and just because I like it, I like creating methods. And the next thing we have here are the x values that are going to be used later on in the functions that I have, that are going to be able to use in the plot class for graphing a lot of, and or plotting, as I should say, these functions that I'll have. So first you have these x values that are like really small and don't go very far. Then you have the longer one that'll like have a more expanded version, of certain graphs. Next thing we have here is min and max, of course. Um, these were very easy, just using basic conditional statements. I also implemented a tiny bit of the bubble sort algorithm to find the maximum value of an array. Obviously, I don't need any while loop in order to sort the entire thing. I just needed it to execute once, so I could only find the max. I don't need to sort it. The same with the minimum, but with the opposite objective. Power was very hard. So the problem that I had with this, trying to calculate the power of something, is the first major problem I had is that I forgot that I needed to create a variable that was equal to the power, to the variable that's being raised to a certain power, in order to be able to use it like this, where it's 5 to the third power, for example. And also this doesn't quite work with values that are less than 1, unfortunately, or numbers that are not whole numbers, I should say, because of the way that I incremented this. Even though I created this using a double, it wouldn't really change much because of the incrementation being by 1, and therefore from 0 to 1 is skipping everything in between that, or really anything between a whole number, right? So I decided that if need be, I would use, unfortunately, um from the math class, I would be willing to use the power and square root, because I also had a similar problem. Absolute value, easy conditional statement, just needed to return the literal opposite of any negative number you inputted. Square root, I couldn't figure it out mathematically. Listen, I tried, but yes, scuffed math is so scuffed that it needs to use the math class still, right? This is just calculates the it just squares a number that you input and cube it. So just multiply it by itself, then multiply it by itself on three separate occasions for cubed. Very easy. Rounding, I'm not going to allow the user to choose how I round it. I just using formatted output just wanted to round it by 2 decimal places. The average, I put a double here, but I forgot that indexing works. That indexing in an array is set with integers because there is no 1.1 index. It is you have a 0 1. It's a placeholder. So I don't know why I try to put double here to go through the placeholders, but I understood how averages worked. Factorial. This is to compute the absolute error of something. This was I remember looking in the math class for Python, and this is what I was influenced in one of the mechanical engineering tech electives I took that sort of went over this a lot. Yep, here's the quadratic formula. I was able to actually use my own power function here. Get the sign. Yep, easy stuff. Had to, return string values. I guess that could be interesting. So let's go now to my own implementations of things that sort of make this class different from the regular math class. I using, my own inner methods inside of this class, as you can see here in these volumes, is that I wanted to compute the volumes of simple shapes and the areas of simple shapes like in geometry. So I wanted to have a bit of geometric functions be added into this class for simple use, like you probably would in a calculator, maybe if you had a very advanced calculator who already had that ready for you. So now in the functions that I had, this is where things become interesting. So first thing to note is that um the first thing I wanted to do is have a line function, just a linear function, y equals mx plus b. This coefficient here represents the m, x values, b. And it just returns um, a double array of the output of what that would come out to for each y value. I did a parabola here using my own functions. I did the cubic function and the reciprocal function, the square root function, quadratic function, and the exponential function. And the ones here are just repeats of all that, but instead it uses the second set array of x values that I ended up using. So these are all very easy to understand. Obviously, the computer science of like using the looping structures, the returns, the method is interesting for the algorithm, but this is very simple math. I just basically looked at a formula and used my methods to write out said formula. In the plotting class here, in order to plot these functions, the first thing to note is that in here you need to define your own array of doubles for x values and y values. So you just need to call scuffmath.xvals1 or just xvals, depending on what y values you want to have. So here I had y values equals scuffmath.line1. So I inputted I didn't want anything to be changed, so I put the coefficient of constant to just be 1. I could have put the constant to be 0, but it won't make much of a difference. I had an array list that contained a 2D rectangle, where if you come down here, basically, I imported the 2D graphics class 2D rectangle. I created a loop that would add to the array list with the x values and y values that I had to manipulate because they were really small, not very spaced out, and in a part of the screen that I did not like, and I made them 5 by 5s in their width and height. So with that, if you plot here, this is what it comes out to. This is what the line looks like. So here in the mathematics class, I just created a new J-frame in order to show it, just in case those who may have needed to know that. So here is the line. So I could set the constant equal to, I don't know, let's say, the coefficient equal to 5. Let's see how that would come out. Alrighty, so the thing that you need to know here is, like, for example, if I wanted to do x values, I just wanted to call parabola, you have to call these yourself, and you sort of have to manipulate the variables for what you want them for. So for example, I don't like the way that these y values look. So in here, instead of multiplying it by 75, I'm going to multiply it by 55 and just sort of see how that changes the graph. Alrighty, not by much, so I'm going to multiply it by 15 and see how much of a change that has. A big change there. Now I'm going to lift this up by 50 units there. And here is the first bit of a parabola. So if I were to include negative x values, which you can go inside of the scuff math and change it, it would come through here, and then you would be able to, so this is just half of the parabola. So if we went to the square root function, I believe I had, I'm not sure what I called it. I think I called it square root. Actually, let me check. So math.sq square root function. Here we go. 1. Okay, now that I need to manipulate a great deal. So let's multiply this by 75. All right, that's much better. So because of the limited x values that I gave, it kind of stops here. So you can go and add on, so it comes all the way out here, and it goes out more. And so that's really all that you need to do. So I'm pretty sure people who are going to use this are going to be computer science majors. So even though I'm sure that they'd rather have a class that would handle these sort of changes for them, I'm sure that they're all intelligent cookies enough to be able to do this themselves. And this is my week project. I give myself a week to work on projects like these. I try and do them as quickly as possible to move on to something else. I also have classes to worry about. So I try and make it, fairly functional in the where there's not much changes that need to be done, where it's like fairly user friendly. I'll keep working on it throughout the week if I didn't think it was user friendly enough. But I think this is a good stopping point for the scuffed math class and plot. Now I may come back to this and add more to make, like in MatLab, which is what I tried to base this off of, it more friendly towards you don't have to really change any of the input, and add more to the scuff math class, like trigonometric functions, which I said I would add, but ended up not adding because I didn't want to have to call them on my own, and I didn't want to have to create a very small library that contained, degree values. So I will probably come back to this someday and add trigonometric functions and make the plot class more friendly, and where it creates a frame for you. It sort of updates these things that it needs. You can really do this on your own by adding more x values, manipulating these, and it should come out the way that you want it. So I hope y'all enjoyed this video.